is something new called integration by parts. Maybe something that you would have tried. I'm going to come up to the board and just play with it. What do you want me to try? X is u is equal to x, then du is equal to dx, so I could make it u sine of u du. Okay, try something else. Come on, you guys know integrals enough. You would have tried at least a couple things, right? What else? How? Well, what would you have equaled, though? Because x, I mean, there's nothing else to really do, right? Okay. So what if u was sine? I'm guessing, right? So if u isn't 1, I mean, yesterday we had one, the cotangent one, Riley. You were like, cotangent, and it didn't work. ln of sine worked. So you go back and you try the other guy. Okay, fine, try the other guy. No big deal. We're CalcBC kids. I told the kids yesterday if we had had more time, I totally would have played it off. Like, you guys can solve this, go. You can't do it yet? Try again. I would have just kept on going. I would have been like, coming back. That's only if we had time. Where would this have led you? You know nowhere. But why would it be nowhere? You could come over here and we could then go ahead and plug in and say, okay, x times, sorry, sine of x became a u, times du over cosine. Now, Aryan was like integration on crack, and that's good because that means you have extra x's, you better go get them into u's. Okay, all right. So we could come up here and say this is gross, but I have faith it's going to work out. So x is equal to sine inverse of u, right? So we could come over here. We could plug in. Sine inverse of u times du over cosine of sine inverse of I mean, maybe you would have been even smart enough to be like, wait a minute, sine inverse of u. That means u over 1 is an opposite over a hypotenuse. So I could go ahead and make this guy with Pythagorean theorem, c squared b squared. So cosine would be adjacent over hypotenuse. So I could actually plug in. No, you guys wouldn't have gone there? We could have actually plugged in and gotten, okay, so we have u sine inverse of u times du over adjacent over hypotenuse. Square root of 1 minus u squared. Wait, but don't you guys see anything right here?
Oh, that's what.
Can we make a v be sine inverse of u?
I'm sorry.
And dv equal to 1 over square root of 1 minus u squared? Du? No, that's the derivative of sine inverse. What's wrong with you all? Well, we already used u, so we wanted to do a u sub, but we have to pick a new letter, so we pick v. Anyway. Yeah. So sine wait, guys, this is good, right?
Not really.
Why not? It will cancel out that guy. What's wrong with you, see? I can go ahead and make this guy, right? The integral of u times sine inverse will be v times dv. But isn't that clever, though? I thought it was fun. Anyway, Kathy's tracking. It goes back to the very beginning. I thought it was funny, too. You're back here. And pause. Didn't even going back to the beginning take a lot of work? Like, you had to do u sub, then you had to do integration on crack, and then you had to use, like, our spiffy triangle thing that you're kind of, like, all balking at even understanding ever at all this year. And then I haven't totally forced you to know it yet. And then over here, you had to use a v sub to help out with, well, that guy's the derivative of that guy. But then we still got back to having like an extra variable, because if you were to solve for, thank you for seeing that. If you were to solve for integration on crack once again, you would end up with u is equal to sine of v. So if you went to plug in, you would end up with the integral of v sine v all d. Well, that was fun. Long story short, all of our ways crumble and fail. Ooh, Sermon on the Mount at the end. This is good stuff. Storms come and the house goes splat. Anyway, coming back. We're back to the beginning. So maybe we should learn this new thing called integration by parts that says, let's talk about a product rule. And let's talk about how when you take the derivative of a product, you get the sum of different pieces. And long story short, rearranging this just a little bit, watch the video from yesterday to see how it worked. It was really quite cool. Rearranging the product rule and then integrating actually gets you to, we can solve for the integral of u dv. What? Two different letters? Yeah. Because a product rule has a u and a v to begin with. Derivative of the second and the first. Derivative of the first and the second. It's a rearranged product rule applied to integration. We can say the integral of a u dv, we can look at an integral as having separate pieces, will equal u times v minus v du. Now this is going to be pointless if this integral is not simpler than it was. This whole thing is pointless. If that thing isn't simpler, well, you're still stuck. But if this is simpler, maybe you can integrate that where you couldn't integrate that. Check out what happens to the u in the rule. Check out what happens to the u in this integral. He's derived. Check out what happens to the dv in this integral. He's integrated. So if the derivative of u is simpler and the integral of v is possible, what was impossible might become possible for me to solve. And that's exactly what happened yesterday for those of you that watched me do integration by parts. I say watched because I would have to say solved with me very loosely. Watched again. I asked yesterday and someone came up, it was Riley, Kathy, someone over there. I was like, which of these pieces would be simpler if derived? And they said x. So I made the u that gets derived in the formula x. The other piece, I was like, man, I sure hope he gets integrated, and he does. Now, you're going to have to do some integration mental math style. Hopefully it won't be too hard, and if it is, hopefully you go off to the side and do it. But you're going to have to integrate, because the original integral has, let me write up the rule. The integral, which sometimes is as it's written, and sometimes it's not, is equal to u times v minus the integral of v du. Someone has some sort of way of remembering this with like ultraviolet and then voodoo. I don't even know. But anyway, it is good. I just can never remember how it actually went. I don't know. So the ultraviolet minus the voodoo or something. And there must have been something for that. I don't know. But the u, I don't even know v. I get u and dv out of the integral. So there's my x, there's my sine of x dx. I derived one, I integrated the other, and the formula says take u minus v du, and look at how much easier that is. So the integral of u dv is equal to u times v minus the integral of v du, or voodoo, and then as you take, dun, 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 it works? Yeah. How could you check? Derive.
Wait, so you just take a u times the derivative of the other part minus the integral of the derivative?
U times the integral of the other part, right? So u times, because one piece gets integrated, the other piece gets derived. So we have to work forwards to one, and we have to work backwards from the other. Yes. Yes. Now, how can we double check? Well, to double check, we'd take the derivative. And the derivative would be second, d first, which would be -1, plus first, d second. Derivative of negative cosine is a positive sign. And the derivative of sine is cosine. Derivative of c is 0. This was a product rule where pieces went away and I was left with. Only integration by parts can get me back to the craziness that came first. Does that kind of make sense? Oh, right. It's not necessarily u and dv. It could be dv and u. That's why I asked you which one's simpler. Don't worry, don't worry, don't worry. Let's take a forever card. Let's take a forever card. Here we go. Because check out the forever card. You choose u. Just like we always choose u, and you have to get a lot of practice in, a lot of experience, a lot of trial and error to kind of get a natural feel for who should be you. And the other day when we first started U sub and we kind of jumped in the deep end, you guys took a little while to get back on track, right? It takes a while to get used to who you should be, just in good old-fashioned U sub. But now we have to figure out from an integral whether or not integration by parts is necessary. And if it's necessary, I have to split this into two pieces. One to be a u and one to be a dv. Yeah?
So say we had a problem that could have been done by integration on that. Could we use this instead?
Sometimes. A lot of integration on crack ones that we've done in the past have been two functions that are fairly similar, like a polynomial and a polynomial with like a radical, like a square root. Those ones are not ideal for integration by parts. Integration by parts is ideal. I'm not saying only used when, but ideal when you have like a polynomial function and something that cycles, like an exponential or a trigonometric or sometimes even a logarithm. That's when integration by parts is ideal. Integration by parts is required when you have two cyclic ones, like a trig and an exponential, or what else cycles? I don't even know what else there is. That's the one that they always use, is trig and exponential. That it's required, but it's not nice and it's not pretty. To integrate, like actually solve for the integral of any just logarithm, just an ln, or just a log with nothing else, you have to use integration by parts. Anyway, Aryan, we'll get a feel for it. Sorry, I missed Justin and Hannah. Justin.
So why is it again that it's the integral of u and then dv instead of?
It's the result of integration to a rearrangement of a product rule. So if you were to move these to the same side, so u dv plus v du, that's kind of like second d first plus first d second. On the other side is uv, so you would derive both sides. Derivative of the integral cancels out. You have your product rule, derivative of, that's the derivative of the product. Does that make sense? So it's a rearrangement of the product rule that's been integrated, basically to meet our purposes. Did you still have a question?
So can you use integration by parts on a lot of other problems that don't necessarily require a statement?
I've seen it done. I'm just thinking of like a kid I'm tutoring in Calculus 2 who's done tons of integrals like the past few weeks. On a couple of them, I think she's used integration by parts where I wouldn't, but normally it just makes it worse. You'll get a feel for when to use it, when not. For instance, this one is a clear integration by parts problem to me. I know. It's a clear integration by parts problem to me. Because if you guys realize, now, if there was a squared, heck no, don't you dare use integration by parts. Why? If this was 3x squared, couldn't you just make u 3x squared? Du would be 6x. I don't mind that guy. He's my du. Forget it. That's fine. But if I have a u being 3x, and I have an extra x with a trig, that's integration by parts every time. So mimic what I did and see if you can follow the rule to its completion. The hint being which piece, x or sine of 3x. No like separating the chain rule. X or sine of 3x, which piece derives to be simpler? X. Riley, go ahead. Yeah. Possibly. which is why I've been trying to get you guys good at mental math integration. That's basic. Does that make sense? Yeah. Because once you start trying to use, so maybe use W's if you need to write it out. Does that make sense? Okay. You guys will see what Riley's talking about because I think she's trying to solve this one. I'm going to show you the way that I set it up. It's not how most college professors set it up because I like calling it Lucky 7. It's just a silly way of remembering. Also reminds you that one goes one way, the other goes the other way. I'll eventually show you other ways of arranging it where you just memorize the formula. But this is how I do it. Once you split up your U and your dV, now it's time to do some work. Do you guys agree with my negative 1/3 of cosine 3x? There is no plus c because this guy's going right back in an integral. I don't need the plus c because he's going right back in an integral that'll have its own plus c. And you guys know all the different plus c1, plus c2, plus c3s can come together. Why is there a 1/3? Yeah, so Riley was saying, wait a minute, do you have to sometimes do u sub to integrate? Yeah. I'm hoping most of it's basic enough that we can mental math it and be like, oh, there's a 3x, oh, du would be 3. Du, no, not that du. Du would be 3. Dx is equal to du over 3. But I was telling Riley you can also use w's now. Like w is equal to 3x. Yay! dw is equal to 3dx. Like you can if you need to, but hopefully we can come back to here pretty quickly. Now what? Either memorize the formula and plug in the right pieces, the right places, or lucky 7. Either way, you should end up with negative 1/3, x cosine x, uv minus v, oh, it's a negative, du. I'm not done, but have you gotten there, or do you see how I got there? I took u, I took v, multiplied the two together, minus plugging in v and du. So u times v minus v du. V gets used twice. Oh, did I not write my... Said it and didn't write it. I know, I'm sorry. It's a new process. You're like, that happens too? No, no, no. Things don't normally disappear. They sometimes appear. Well, I guess they disappear. Derivative of c is 0. Anyway. Oh, dear. Now does it make sense? Okay. So now we finished, right? No. Because they're asking for the final product, and the final product needs to have it fully solved. Not simplified, but solved. Although I did hear the other day at a certain math conference in Palm Springs that you are allowed on the FRQ to leave trig unsimplified. Maybe that changed. There's a few changes. There were a few changes. L'Hôpital's got way worse. It's okay. As far as what you write, justifications got way worse. As far as what you write. Yeah, but more. Anyway, but it's okay. We're fine. We're moldable. Right? We're not stuck in our ways. Anyway, you guys are young. You can adapt. If you guys are doing mental math with integration, I am very proud of you, but please, please, please be careful. You have to use the U sub. I wonder what other people hear when they hear you've got the plus C. They're like, what's that? Yeah, a lot of people do. Do you guys agree? Okay, guess what? That was like the most basic example ever. Yay! Let's go. We'll see, we'll see, we'll see. Homework is due attempted tomorrow, but as Issa said, on the calendar it says more integration by parts tomorrow, except we also start 7-4, which is partial fractions. It's pre-cal, yeah, it won't be bad. Submit pictures of how much you were able to attempt, but I'm not expecting the full. You missed yesterday. We did partial fractions. Don't worry. On the BC test, AP, all the ones that I've seen, you can use the cover-up method and not even have to do the long work. But we'll review some of the long work. Pre-cal partial fractions is harder than CalcBC partial fractions. Whole thing. Whole thing. Integration by parts, you can't do an outside-inside. Integration by parts, they have to be multiplied. You should derive ln of x. Because we don't know how to integrate ln of x. We have no clue. And integration by parts, there are no matryoshkas. Like we can't say u is an outer shell and v is an inner shell. No, 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 it's product rule. Because we can't, for u, it needs to be u times v. That was the original product rule. I can't say u of v. Pause. You're learning today. I'm exposing things to you today. Pause. Come on. I told you what it is. Just go for it. I told you what it is. Just go for it. The struggle, learning new material, I don't know. I need to be writing it. Like that's how my brain works. So I realize it's hard to visually, auditorily process new material without actually being in it. I don't know. You choose. Yeah. But it's just going to be a little harder because you're not able to. But can you? You made it simpler. Maybe you need to do integration by parts.
Are you kidding me?
Oh, if you're going to start freaking out now, just wait. Oh, come on. Don't be babies.
Minimum 6 or 7 steps. No more than that.
But it's really not, right? It's just integration by parts to solve that integral. I mean, yeah, in the context of the whole problem, you're doing it within, but you're just solving an integral. Yeah, it is.
How do you show this work?
How don't you show this work?
How don't you show it? We're making new people,
No. You have the integral, right? Like, you're just solving an integral. It's not a big deal. Like, it's not really within. It's just kind of like, oh, I just need to solve that guy now. Okay, I'll do an integration by parts for that guy. Uh-huh. Yeah, right? But it's so much better when you get there yourself and you're like, yay, x over x, beautiful. Now careful. When you go to do Lucky 7 integration by parts, whatever you want to call it, when you go to do that, isn't that solving this integral, which is being multiplied by 2 being subtracted from this? You have to keep it where it needs to go. But I'm solving this integral, so this piece will get replaced by my new uv minus the integral of v du. Well, x over x is 1. I can do that. My final answer. Oh, it's so easy to forget plus c on integration by parts because you're like forgetting plus c all along. You're integrating and not actually putting plus c, and then all of a sudden the very last one, don't forget. Now. Sorry, I got so behind this year. No, right? It's a struggle. Like integration by parts, it's so easy to make a mistake here that you wouldn't have ever thought you would make. Yeah.
For that integral right there was the minus integral and there's just 1. Is that supposed to be an x?
X over x is 1. Sorry, I just didn't understood 1. Yeah, x over x, x times 1 over x. What? Didn't you guys just realize that if there's a log by itself, you better try him as you? Twice we learned that. There are some guidelines for integration by parts. Try letting dv be the most complicated thing that possibly you could integrate, that you could possibly integrate. But if you go a little too far, it's all of a sudden impossible to integrate, and you're like, oh no. So let dv be as much of it as possible that you can actually integrate. And let u be what's left over, or let u be a piece that will be so much nicer if derived, and let dv be the rest of it. dv has to always include the dx, but here's a hint in general for how to choose u. Liate. Liate. If you have a log, and it can't be dealt with by normal u sub. You guys have done some logs, but that have also had like 1 over x's, the things that help. If you just have a log, or like the last one, a log squared, that has to be u. We have no way of integrating just ln unless we memorize what happens with integration by parts when you do ln as u, which is what the rule was that was on the screen at some point. If there's a log, but there's inverse trig, a sine inverse, a cosine inverse, we can't integrate a sine inverse or a cosine inverse, but we can derive him to something that might integrate nicely. Inverse trig is like logarithms in the sense of if it's in there in an integral, we're in trouble if there's not a u du that's nice and waiting. If not logarithms, aka something like a polynomial. If not algebraic, okay, I guess trigonometric. And then if I guess trigonometric isn't there, then I guess exponential. This is the order of what to look for. Is there a log? Well, nope, then that's not you. Is there an inverse trig? Nope, well, that's not you. Is there a polynomial something? Nope, that's not you. Kathy. No. 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 I mean, the only thing I can think of is if you add, like if you rearrange the formula, but no. We keep it one way. That way we're always looking for the same thing. Can I take you guys back to, where was that page? All right, you know what I'm talking about, where the ln rule was, right? Ooh, that was it. Yeah. Some people have you memorize a rule for ln, the integral of ln. Could I? I suppose. Could you? I suppose. But check it out. Where does it come from? This comes from integration by parts. Sorry, I didn't want to use u's because I'm using u's in integration by parts. Could you memorize what happens every time you take the integral of ln? I suppose. Could you just do integration by parts? Yes. Yes, we missed even and odd, but I'm hoping we're okay on that, and if we ever need it, we'll remember it. Why is there a random blank page? I don't know. Let's get rid of him. Okay. So what about him? There's a log. Liate. Oh, there's not. There's an inverse trig. Liate. Oh, no, that's not it. Algebraic. Exponential is not until the end.
Oh my gosh.
Algebraic. Is there anybody who's algebraic?
X.
Yeah. Go. Let's see if you guys can get to the end. Okay. Sorry, I'm having too much fun playing today. Don't worry, there's one that slows me way down and I always forget how to do it. And I hope and remember that you guys find it before I do. It's not till the end, though. Oh, come on. E to the U. Negative 1/4. Oh, I had breakfast. Where's my breakfast? There it is. You can just grab your phone on the way out. Go straight to class. Thanks, kiddo. Can I play? So salty right now. You didn't do U sub. U is negative 4x, du is negative 4dx. Oh, from there. uv minus v. Minus a negative is a plus. Need a negative 1/4 for my u sub. Some of you, it's going to take time, and that's okay. What I'm asking for tonight is to get as far in homework as you can, post the submission of the attempt. Does that make sense? Tomorrow come, we're going to keep practicing an integration by parts. Maybe tonight watch a Khan Academy or a Patrick JMT. Maybe this weekend watch a Khan Academy or a Patrick JMT. Or there are other good tutors. There's the one who has like a lazy eye a little bit, but she explains things really well too. She's cute, but she has a little bit lazy eye. I forget what she's called. But there are good ones. Watch some integration by parts. It's all over the place. It's a huge CalcBC topic. But do we have the idea? Do we know that the exponential should not be a part? We're guessing so, right? But doesn't the e to the x squared, doesn't he need an x to be derived? Sorry, to be integrated? Because 2x, I need an x there or else I'm... So then we could make this guy or, well, I'm just being devil's advocate right now. Or, what would be another way of putting something complicated in the dv that can be integrated? Couldn't we also do... Couldn't we also do... Couldn't we also do this? Wait, couldn't we also, because we just need an x for, but couldn't we also do that and do integration on crack, or do that and do integration on crack? And we could just do this? We're not going to finish this in 35 seconds. My question to you is, which one works? Only one does. Maybe you should figure that out before tackling homework. You're welcome. What can I say except you're welcome?